Hello everyone, this is Nagamanaswini from 9th Olympiad Narayana SMPSG. Today we are going to go on a seminar through gravitation, that is very most important and interesting topic in our physics. So gravitation. So I will give a brief introduction about gravitation. When we see an object falling from certain height, we feel that earth attracts it. But is that true? Is that force really attracts? Is the earth really attracts that object from height? So we are going to do that. If same in this scenario, we will compare the space, the moon, planets, all everything with the sun. The motion of planets around the sun, is that true? Is that true? We say that the force between the sun and moon and the sun and the planets is gravitational force. And Sir Isaac Newton said that the same force is responsible for the fall of a object from a certain height and the moon revolution around the sun on earth. So let's go into our topic without any delay. One day, Isaac Newton was sitting under an apple tree and he was thinking something. So suddenly an apple fallen from the tree, and Isaac was sitting under the tree and he was thinking why the apple was fallen from the certain height and it was fallen towards the earth. Why can't it go upwards the earth? That was the question raised by him. He was thinking on thinking and thinking and stuck at one point. What's that point? If the earth can attract an apple, why can't the earth attract the moon? That was the question raised by the Newton. So, in this session, we will go through what is that true? Really, the Isaac said, we are going to prove that. So, firstly, okay, let's perform an activity to know the motion of the moon. Because we, before going to know about the revolution of gravitational force, we have to know about the motion of the moon. What's making the moon to revolve around the earth? So, let me take a. Okay. First, take a thread and take a stone and tie the stone to the thread at one end and take the hold the other end and just drill it out around. So after some time, just release the thread. What happens? The thread moves in the tangent of the circle. Before the thread is released, the stone will be moving in a circular path with certain speed and change in direction at every moment of the circle, every moment of its place. So, if there is change in direction, there must be change in acceleration and change in velocity. If there is change in velocity, there must be acceleration. If there is acceleration, acceleration involves a force. There is a force. We fix that if when we drill an object in a circular motion, there is a force acting on that object. The force which is making the object to move in a circular motion and acts towards the center. That force is known as centripetal force. In centripetal force, we are having a very huge topic about centripetal force. Let's go and discuss that in other topics. So, that force is called centripetal force, and let me give a clear definition about centripetal force. When a force is the force makes the object move in a circular motion and acts towards the center. Acts towards its center. That force is known as centripetal force, and it is also known as center-seeking force. So now we discussed about before the thread is released. Now what happens after the thread is released? After the thread is released, the object and the stone will move in the tangent of the circle. When the object is moving in a tangential direction, there must be absence of the centripetal force. So now the Sir Isaac Newton said that see that apple falling, we saw that apple falling attracted towards the earth. Does the apple attract the moon? Does the apple attract the earth? If earth attracts apple, why can't apple attract the moon? That was the other question raised by him. So he again said that there must be some interlink between them and the moon and the earth. So he said that according to the third law of motion, that is For every action there is an equal and opposite reaction. According to that, he said that it is possible that apple can attract the earth. And again we are having the mass. Mass of apple is small and the mass of earth is very huge and it is negligible. According to second law of motion, force is inversely directly proportional to mass, MA, mass into acceleration. As from that, he took that mass of apple is negligibly small when compared with the earth mass. So, he concluded that the same force responsible for making the apple fall downwards and the moon to move around the earth. The same force is responsible, he concluded. The Newton concluded that the same force is being. And after all these debates, arguments, facts, he just said that the same force responsible for apple to fall down and the moon to revolve around the earth. The force between any two objects, the force of attraction between any two objects is said to be gravitational force. Okay? The force between any two objects, mass m1, m2, the force of attraction between these two objects is called gravitation force. Let me give a there is a one law that states that universal law of gravitation, that is every object, if it is satisfying gravitational force, it must be satisfied force is directly proportional to product of its masses and inversely proportional to its distance, square of its distance. These are stated by him. If the force between two objects if we say that is gravitational force, then it must satisfy these two conditions. Let me think this is first equation and this is second equation. Let us derive the formula for gravitational force. F is directly proportional to m1 and m2 by d square. When we combine the two equations, F is directly proportional to m1 m2 by d2. So to remove this proportionality constant, let me keep a gravitational constant g, and m1 into m2 by d square is the formula for gravitational force. And from this, G. G is the universal law of gravitation and value of G is 6.673 into 10 to the power of minus 11 Newton meter square by kg square. This was given by a very great scientist, Henry Cavendish. And next, let me give the importance of this gravitational force. This force helped us to explain several phenomena such as the force which binds us to the earth and the force which binds us to the every object in the universe, not only planets, something. All the universe is bound with a force and we are bounded with that force. And next, the application of this gravitational forces. This helps the moon to move around earth, and it even gets the tides from moon and sun. And after that, let me give a small example to find gravitational force. An example. What is the magnitude of gravitational force between earth and 1 kg object on the surface? What is small m? 1 kg. And what is capital M? That is mass of earth. What is mass of earth? 6.4 into 10 to the power of 24 kg. 6 into 10 to the power of 24. And radius of earth is 6400 kilometers. And let me give a solution. F is equals to G into M1 M2 by D square. Instead of D square, let me give R square. Why? Because we are having information about R radius of the earth. So we will take R square. So G is nothing but 6.673 into 10 to the power of minus 11 into 1 into 6 into 10 to the power of 24 by 6.4 into 10 to the power of 2 whole square. When we simplify this, we get 9.8 Newton as the gravitational force between the two objects. So, from this, I conclude that thanks for listening patiently. Thank you for giving this opportunity, sir. Thank you.
Give claps.